Wednesday last week, we had just touched on tree diagrams. So for those of you that weren't here on Wednesday, we're still going to look at that. We're going to get into more complex type questions. Just quickly, a tree diagram is a useful way to show all possible outcomes. So whatever we're looking at, if we are throwing a dice and throwing a coin at the same time, for example, we see all the possible outcomes that could possibly happen when you throw those two things together. Or if you're looking at different kind of outfits, you're looking at 2 different color shirts, 2 different color pants or skirts, all the different combinations you can get by doing that thing. So we're going to try the first one together. I've already mentioned this type of scenario. It says, draw a tree diagram showing all the possible outcomes for tossing a coin, then throwing a dice. So based on how this was worded, the coin tossing is going to happen first, because then they say then throwing a dice. So that means the coin needs to come first in our tree diagram. And generally, in the order of the question is the order of the tree diagram. So if the coin's mentioned first, you put the coin first in your tree diagram. So just to remind ourselves, we're going to do this together. So when we start the tree diagram, I always just put the heading. You don't need to put this in, but I'm going to look at the coin first. When you toss a coin, you have 2 options. You either can land on heads or you can land on tails. Okay, then the dice is thrown. So you've thrown the coin. Now let's say it lands on heads. You're now going to throw the die, because it's going to be 1 dice. Okay, and that could land on either 1, 2, 3, 4, 5, 6, because there's 6 sides. So 6 sides, sorry. So you could land on heads, then you could land on 1 with the die. Land on heads, then land on 2 with the die. Or 3, 4, 5, 6. Okay, and that's where our tree diagram comes into play, because they are little branches making up. Diagram over here. I'm just going to move it down. Obviously, with tree diagrams, the spacing does get a bit iffy. So my advice is always draw in pencil first and leave enough space. So we've got our tails. So let's say, for example, your coin lands on tails. You then throw the dice, you get the same options again. You can land on 1, 2, 3, 4, 5, and 6. And then remember, the most important part of the tree diagram is to actually see our outcomes. What are the possible combinations that can happen by throwing these 2 things or tossing them up in the air? So you could land on heads with the coin and 1 with the dice. Heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. So just quickly, that's me reading this part first and then following the branch to get H1, H and then 2. So that's how we read our outcomes. Or you could land on tails and then land on 1 with the dice. Tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. Okay, and then another important thing that we need to remember is actually counting all the possible outcomes, all the possible combinations you can get, and that would be 12 outcomes. Okay, everyone happy with that? Any questions? If you have any questions, let me know in the chat. This was just a quick little reminder on how to draw a tree diagram. Cool. Nice, Shima. Great. So now looking at our tree diagram, we're going to answer the following questions. How many outcomes are there? So because we did our tree diagram nicely and filled everything in, we can see straight away that we have 12 outcomes. It's already there for us. So we can just say 12. Nice, Benele. Thank you. Then, what is the probability of getting each outcome? Write this probability as a fraction, a decimal, and a percentage. Okay, so now we need the probability. What is the probability of getting any one of these? What is the probability of getting T1? What is the probability of getting T3? They each have an equal chance, and that chance is what? Anyone want to try it in the chats? Let's see. Nice, Shahima. On fire today. Okay, so every possibility has an equal chance. The probability is 1/12. There are 12 outcomes, and each of those has one chance. Okay, they also asked us to write this in decimal form. So if we put that in decimal form, we get 0.08, and they ask for percentage, which gives us 8%. Okay, so just a reminder, we did practice this last week. Once we have our fraction, we can just press the SD button on our calculator. It will then give us the decimal answer. And then we just times by 100 if we want our percentage answer. Nice, Shahima, well done. Okay, then, how many of the 12 possible outcomes include getting an even number on the dice? So just quickly, how many of the 12 possible outcomes? They're not asking for the probability. They just want to know how many outcomes include an even number. So looking at our outcomes, we go and count. There's an even number, there's an even number, there. So that is 6. Well done, you're all getting it. Awesome, okay. How many of the 12 possible outcomes include getting tails and an even number? So tails and an even number. So we look to see where we see T in the outcomes, oh sorry, an even number. So that is just these 3, which I see you all got. Well done. And then the last question before we try another tree diagram, how many of the 12 possible outcomes include getting a 5 on the dice? So how many times do you see 5 in our outcomes? You see it over here and here. And I see. We're getting 2, 2, 2, 2. Nice. So let's quickly check. Question 5. Okay, so let's just quickly answer question 6. It is 2 outcomes. It is heads. Okay, so you asked me to quickly explain question 5. So it says, how many of the 12 possible outcomes include getting tails and an even number? So that means we need to look at all the outcomes. We don't include any of these because they don't have tails attached to them. So we just look at the tails section. So it has to have a T in front, but it must also include an even number. So it can only be T2, T4, and T6. So it's only 3 outcomes out of all of them that include tails and an even number. Let me know if that helps. There we go. Cool, pleasure. Nice, guys. So it looks like you're understanding this. So now it says, we're going to try this one on your own. At a local high school, the boys' uniform consists of a pair of pants and a shirt with the option of wearing a tie. The pants may either be long or short, and the shirt may be either long sleeve or short sleeved. They are allowed to wear any combination of these 3 items of clothing. Draw a tree diagram to illustrate all the possible combinations of these 3 items of clothing. So just to lead the way quickly before I leave you be, we are looking at pants. So we're going to put pants first in our tree diagram because it's mentioned first. Then we're looking at shirts. Can be long sleeve or short sleeve. That will be the second part. And then we're looking at a tie or no tie. So there are 3 options: short pants, long pants. Then shirts, short sleeve, long sleeve, and then tie or no tie. Okay, so let me help you out with the headings quickly. So it'll be our pants. And I think just use abbreviations. The pants options are long or short. So let's say long pants, short pants. So LP, SP. And then you can abbreviate the shorts, the shirt, sorry. Long sleeve is LS and short sleeve SS. Tie, you can say T for tie and no tie, NT. Okay, so I'm going to ask you guys to try fill in this tree diagram for me. I'm going to give you a couple of minutes to try. Do it in pencil, just because spacing can sometimes not be your friend. Let me know if you want some help. Don't forget about the outcomes column and to total the outcomes. Hey, give me a thumbs up if you're done in the chats. If not, it's okay, you can carry on. Just want to see where we're at. Nice.
It's good to go.
Nice and Sako. Also, super quick. Nice, Shahima. Nice, no. Okay, so I'm getting quite a few thumbs up. So I'm going to quickly go through it. I think it's going to be a little bit hard to show me your answers in the chat. So yeah, let's quickly go through this. So our pants options is long pants, short pants. So let's say, for example, a learner chooses long pants. Now they have two options for shirts. They can wear a long sleeve shirt or a short sleeve shirt. Okay, if they choose long pants, long sleeve, they've got an option of tie and no tie. Or they can say long pants, short sleeve shirts, and have an option of tie and no tie. Okay, then they could choose short pants as an option, and their shirt options is long sleeve, short sleeve, and again, if they choose long sleeve, they have the option of tie, no tie, short sleeve, tie, or no tie. So if I follow my branches, if I go long pants, choose long sleeve, and tie, that gives me the outcomes of LP, long pants, long sleeve with a tie, or long pants, long sleeve, no tie. So that would be long pants, long sleeve, no tie. Okay, or we could have long pants, short sleeve, tie, long pants, short sleeve, no tie. Okay. Or we could look at short pants, long sleeve, tie. Short pants, long sleeve, tie. Short pants, short sleeve. Sorry, still long sleeve. Long sleeve with no tie. Short pants, short sleeve with a tie. Short pants, short sleeve, no tie. Okay, so you wouldn't think that you would actually have all these different kinds of options with these three items of clothing. So last thing, we need to count how many outcomes there are. So there's 1, 2, 3, 4, 5, 6, 7, 8 possible combinations with these three items of clothing. How did that go? Do we have any questions? Thumbs up, smiley face. Let us know. Was it good? Do we need some more work? Awesome. Smiley faces, winky faces. Nice, nice. Sanile, you kind of lost a little bit. Okay, so just give me 2 seconds. Okay, Sanile, can you tell me kind of exactly where it started going a bit haywire? Okay, so just let me know in the chats and the whole scenario. Okay. So just looking at the whole scenario quickly, quick summary is that we have 3 options of clothing. Okay, we have our pants, we have our shirts, and we have our tie. And all we do is basically list all the options. So when it comes to pants, we mentioned pants first in the scenario or in the tree diagram because they mentioned pants first in our question over here. So we look at pants, we have a long pants option, short pants option. So you write those 2 options down. Then you could be a learner who chooses long pants. So let's say, for example, you physically have chosen the long pants. Now you need to choose between the 2 shirts. Your 2 options is long sleeve or short sleeve. So you draw 2 branches out from the long pants in the tree diagram. Okay. And then same thing with the tie. So let's say you've chosen long pants, you're now choosing long sleeve, but you still have an option of choosing tie and no tie. So once you've chosen one of the options, it always branches out into what is next. Okay, so I think for now, Sanele, just let's see how the next one goes. And then we might need to just explain the tree diagram a little bit more. Okay, so let's have a look at this question. Maybe this one will help as well, Sanele, because you don't have to draw a full tree diagram. We're just filling in missing things. So like I mentioned on Wednesday, they could ask you to draw a tree diagram, fill in missing things in a tree diagram, or just answer questions on a tree diagram. So we've looked at drawing a tree diagram. The next question looks like we need to fill in some things. So it says, a customer has 3 meals to choose from: a 2-piece McWing, a McDouble burger, and a McChicken burger. So there are 3 options to choose from. What is the probability that the customer will choose a McChicken burger if he has an equal chance of choosing any one of the 3 meals? So this has got nothing to do with the tree diagram just yet. What is the probability of choosing a McChicken burger? Any takers on the chat? Probability, McChicken. Yo, Shahima, this looks like it is your chapter, your topic. You've got this.
Yeah, no, hey.
Okay, so by choosing McChicken, that is 1 out of the 3 possible options. And we always put a fraction as our answer, unless they ask for a decimal or percentage. It's a fraction, so we check if it's simplified. It is indeed simplified. And I was actually quite nice this time. I gave you the mark allocation. So a question like that would be worth 2 marks. You would get a mark for the correct numerator and correct denominator. Oh, nice. So this is just a little refresher from school. Nice, Noncle. Okay, let's have a look at the next one. The customer wants to add to their meal and has 2 sides to choose from. They can choose between fries and corn. Okay, so let's keep that in mind. First question says, complete the tree diagram to illustrate the various options the customer has to choose from. So this is worth 3 marks. So we are filling in the 3 missing parts. So the first one is our fraction. So we can maybe say A, B, and C. What would we say A is? Good. 1 out of 3. Remember, we have 3 choices of meals. So wings is 1/3, the McDouble is 1/3. And B, what would B be? The McChicken. Good. Okay, so we find that answer in the question. It's just one of the 3 meals they mentioned. And C would be corn. Yes, you guys beat me to it. Well done. Okay, so I'm going to make this look a bit better so it's easy to read from now. Okay, so we've got 1/3 here. Mac, chicken, and corn. Okay, so if you manage to get all 3 of those correct, that would be 1, 2, 3 marks for you. Well done. Then, using the tree diagram above, determine what the probability is that the customer will choose a McDouble burger and fries. The probability that the customer will choose a McDouble burger and fries.
Now everyone is silent.
Anyone want to try? Okay, so there's 2 ways you can do it. I know that fractions have been thrown in the mix here. So the first way you can do this is by saying the McDouble burger fraction, which is 1/3, times by the fry fraction, which is 1/2. And you can just times those 2 fractions. So it'll be 1/3 times by 1/2. Okay, so that's a new way to do it. Or if you just stick to your normal way, if we had total outcomes here, 1, 2, 3, 4, 5, 6. Oh, I see they haven't actually given us the outcomes necessarily. Okay, so it would be Mac wings, fries, Mac wings, corn, Mac double, fries, Mac double, corn, Mac chicken, fries, Mac chicken, corn. 6 outcomes. Okay, and how many times do you see Mac double and fries? It's just the 1 out of the 6 possible outcomes. Okay, so you can use the fractions, you just times the 2 that you're looking at. So we're looking at the McDouble. McDouble is 1 out of 3 chances of being chosen. The fries is 1 out of 2 chances of being chosen. Times the 2, you get 1/6. Or you work out the outcomes and do it like we usually would and see that it only happens once out of the 6 possible outcomes. Okay, so Shahima, got that? Well done, Ditle. Any questions with that? And it's totally okay to do it either way, whichever makes sense for you. I know you guys are used to doing it this way, and that is fine. And again, that was for 2 marks. So it's literally for the right numerator and the correct denominator. Okay, let's try another question. Okay, so now it looks a little bit confusing. There's some fractions involved there, but before we stress about that, let's just read the question first. It says, Lerato has an important meeting scheduled with her employers to discuss a possible salary increase. While getting ready for the meeting, Lerato is undecided as to what she is going to wear. She must choose between 3 different colored pants, black, gray, and brown, and 2 different colored blouses, red and green. Okay, so again, we're looking at a clothing situation. First question says, complete the answers for A, B, and C on the tree diagram to complete the possible combinations she can choose from. Okay, so quickly work out A, B, and C for me. When you've got the answers, you can let me know what A is in the chat.
Panel is just giving us all the answers at one go.
Okay. Okay. Okay, so for A, it is the fraction, which is 1/3, because there are 3 options and brown is the 1 option out of the 3. B is the color pants that we're missing. So we've got black, gray, and brown. Black and brown already mentioned, so B must be the gray pants. And C is our options for the blouses. And our blouses are red and green. We've already got red here, so C must be green. And it looks like all of us got that. Nice. Okay, so if you guys ever have to fill in a tree diagram, it's going to be full marks for all of you. Nice. Okay. Calculate the probability that, Larato would wear black pants, a green blouse, and black boots. If the probability of it choosing black boots is 0.35, write your answer as a decimal. So this is something new. Any takers want to tell us how we would do a question like this? So getting black pants and a green blouse, that is all fine and well. Black pants, green blouse is over here, black, green. So this would be our outcome. But they don't mention boots, but they tell you the probability of boots. So what do you think we're going to do? Okay, so let's start off small. What is the probability of wearing black pants and a green blouse? Just that, black pants and green blouse. Let's not think about the boots yet. Black pants, green blouse. Nice, and cycle 1/6. Okay, so this is our black pants, red blouse. Black pants, green blouse. Gray pants, red blouse. Gray pants, green blouse. Brown pants, red blouse. Brown pants, green blouse. So I don't really have space underneath, but that is 6 outcomes in total. Black pants, green blouse occurs once out of the 6. So the probability of just wearing black pants and a green blouse is 1/6. Okay, so that part is normal. That's you all are comfortable and confident with doing. And I see that you all got that. Yes, is it Shawnee? So now we take our probability of the black pants, green blouse, and we times it by the probability of the black boots. Now, boots aren't part of this tree diagram at all. So that is why they gave us the probability. If it was involved, we just answer the tree diagram as per normal. But because boots aren't involved, they have to give us the probability. And we just times the 2 probabilities together. They ask for our answer to be in decimal form. So you work that out in your calculator and you should get an answer of 0.058. But we know that our answers should always be to 2 decimal places. So it'll be 0.06. Well done, Shawnee. Any questions? Do we feel a little bit better after the explanation? This is a new question. We haven't looked at one of these before, so don't feel too alarmed or stressed just yet. Everyone happy? Nice, Apiwe. Okay. So just to clarify, we work out the probability that we do know in the tree diagram. So we worked out black pants, green blouse. That was fine, getting the 1/6. Then we just times by the probability that was given to us. Okay, so when in doubt, we just times in the probabilities together like we did in the previous one, where we took the probability of the McDouble over here times the probability of fries. We times the two together. The only difference is this time the second probability was given as a decimal, but we are still timesing. And this just wasn't in the tree diagram, but it was still given to us. Okay. Let's have a look at the next question. When arriving at the meeting, Larato notices that the boardroom has 3 blue chairs, 2 red chairs, and 4 brown chairs. A co-worker was already seated in one of the brown chairs. Determine the probability that Larato would also select a brown chair to sit on. Write your answer as a fraction. Okay, I'm going to leave you guys to try this one quickly. Neatly, half of that answer is correct. Vanille. And Shawnee, no. Try again. Apiwe. So it's a little bit different because someone is seated in the chair. So we take in a chair out of the equation. So how many chairs are there in total? Then we need to take one out of it. And we need to focus on brown chairs by themselves. Nice and Sako. Vanilla, yes. Yes. Yes, Lee. Nice. Okay, I can see the correct answers flowing in now. Great stuff. So, pleasure, Vanilla. So, let's have a look. 3 blue chairs, 2 red chairs, 4 brown chairs. That makes 9 chairs in total. Okay, 9 chairs in total. But one person is already sitting on a chair, so we're going to minus 1 chair. Because that can't be included because there's no possibility of sitting in that chair. It's already been taken. So there are 8 chairs up for grabs. Okay, and if we're looking at brown chairs solely, it is, sorry, there are 4 brown chairs. However, the person seated is in one of the brown chairs, so there's only 3 brown chairs left out of the 8 chairs that are left standing. And again, that would be for 2 marks. Correct numerator, correct denominator. Nice. Nice, Anele. Good. Good. Looks like you all got that. So that was a little bit of a trick question because normally it's just what is the probability and it's straightforward. This time they've taken one out, but you all picked up on that. Well done. Okay, so now I'm going to show you guys another question, another way that a tree diagram can be asked. So it's a little bit different. Don't freak out just yet. So we used to seeing fractions next to our little branches. Now this time it's just in decimal form. So nothing different, it's just in decimal form. So Kaiser Chiefs has a match on Saturday. The weather forecaster predicts that there's 30% chance of rain on Friday. Okay, so before I read any further, 30% chance of rain on Friday. If we look at our tree diagram, Friday is first, and the chance of rain is over there. And as you can see, it's 0.3. That is the same as saying 30% chance of rain. If you convert 30% to decimal form, it will be 0.3. Okay. Then it says, if it rains on Friday, the chance that it will rain on Saturday is 60%. So Saturday is 60% chance of rains. We're looking at Saturday, chance of rains. We look at the rain part. We can see it says 0.6, which is the same as 60%. If it does not rain on Friday, the chance that it will rain on Saturday is 20%. So this has not been put in the tree diagram just yet, but that is useful information for when we need to fill it in. Okay, so I'm going to ask you guys to try fill this in. If you have any questions, you can ask in the chat. But I just want you to try figure it out, and then we'll go through it step by step. So the question is, complete the tree diagram below by using the information above. Give your answer correct to one decimal place where necessary. So we're filling in all the decimals, and rain, no rain. So remember, percentages are out of 100. Okay, so I'm going to help with A, just to check if we're all on the right track. So the first two options on Friday have to equal 100%. By saying 0.3 on the side here, which is 30%. So if there's 30% chance of rain, that means there must be 70% chance of no rain. If you convert that percentage to a decimal, it will give you 0.7. Nice, Benele. Woo! On fire. Those of you that are still busy, you can still grapple with it a little bit. Just remember, key thing is that always needs to add up to 100%. Well done, Nsako. Well done. Great job. Okay, so just a reminder for how I worked out A. percentages are out of 100, always needs to be out of 100. They told us that rain, there's a 30% chance of rain. So if there's a 30% chance of rain, that other 70% must be allocated to no rain. There must be a 70% chance of no rain. So these two added together have to equal 100%. Percentages are always out of 100. So this is 30%. This must make up the other 70% to get us to 100. Okay, and purely because they've put decimals in this tree diagram, I just converted the 70% to 0.7 in decimal form. So our percentages always have to add up to 100. So if we've got the 1%, we say 100 minus that percentage to get what the other one must be. Okay, do we have answers for the others? B, C, D, E, F. I've gotten, I think, 2 responses. If you guys are ready to share your answers, you can. Don't worry, Shahima, as long as you can do these questions. If not, remember you can check the recording a couple hours after this lesson. Okay. Let's have a look at filling in B. So let's say it does rain on Friday. That means there'll be 60% chance of rain on Saturday, but we need to work out the percentage of no rain. I say 60% because 0.6 in percentage form is 60%. And remember, our percentages have to add up to 100. So if that is at 60%, no rain will be at 40%. And 40% in decimal form is 0.4. So B is 0.4. Okay, then they didn't put any decimals in the diagram over here. However, they did mention that if it does not rain on Friday, the chance it will rain on Saturday is 20%. So chance that it will not rain . 20%, sorry. So 0.2 over here. And if it's 20% chance of no rain, that means it will be 80% chance over here. And that in decimal form is 0.8. And then we just follow the rain, no rain pattern for E and F. So C is 0.2, 20% because of what they told us in the question. And then we know that the other one must be 80% because the two added together should equal 100%. And then E is rain and F no rain. Do we have any questions? How do we find that question? Not too bad. Okay, let's try this last one. Good, Nay, I'm glad that's not so bad. Determine what the probability will be as a percentage that it will not rain on Friday or Saturday. It will not rain on Friday or Saturday. How are we going to work this out? That it will not rain on Friday and on Saturday. So we know we're timesing two things. Which two numbers are we timesing? Okay, so if we look at Friday, we have rain, no rain. So we're wanting no rain on Friday. So no rain is going to be 0.7 times by. So now we're still looking at the no rain side over here, but we want no rain on Saturday as well. So that is our 0.8. So it's 0.7 times by 0.8. Which gives you 0.56, but they ask for the answer to be in percentage form, so we times by 100, so that gives us 56%. Let's see what we got in the chat here. Nice, Anile, nice, Shahima, good. Nice. So is it getting a little bit better, Sanile, after trying these other ones? Nice, Anile. Okay, so just quickly, again, we're looking at no rain specifically. So that was over here, it was 0.7. So we continue with this part of the tree diagram and we look at the no rain again on the Saturday, which is our 0.8. We times the two together, just like we did with the fractions in the previous question. We get our answer, but they want it as percentage. So we just convert it by timing by 100. Cool. Okay, so I have tried to ask as many different questions with tree diagrams today as possible. So involve some decimals, involve some fractions in the tree diagram, practice drawing tree diagrams, filling in tree diagrams. So how do we feel about tree diagrams after today's lesson? Hopefully really, really good. They are a bit tricky. Do you think you need a little bit more practice with tree diagrams? Okay. All right, good. So it looks like, okay. We're on the same page. Okay, good. Don't worry, Ntando. Okay, so it looks like we're all on the same page when it comes to getting some more practice. So we'll work on that for the next lesson on Wednesday. So Wednesday is our last lesson on probability. We'll do a little bit more tree diagram questions as well as two-way tables, and then we're done with probability. So yeah, I hope to see all of you on Wednesday again. But before you go, can I please ask you to fill in the poll quickly? Oh, okay, you have started it, Ted.
I'm on my A game. Like everyone else in here.
Super fast.
Just 4 more people to answer the poll for us. 3.
Okay, so while we wait for that to be completed, thank you so much for coming today, guys. You did really, really well. It was quite a lot we did today. We got through quite a few questions, sorry. I'll see you all on Wednesday for our last probability lesson.